Hi, so in this video, we are going to solve for a displacement time graph, a position time graph, uh, from a velocity time graph. If you haven't watched my previous video on how to go from the position or displacement time graph to the velocity time graph, you're going to want to do that. Also, if you haven't watched the video on how to solve for the area under a curve, you're going to want to do that as well. We're going to put these concepts together. So to go from the velocity time graph up to the displacement or position time graph, we start off by taking the area of each of the sections in the velocity time graph. The area of the first section, which is located right here, is going to be length times width. So it would be 2 times 3 or 6. In the next region, there is no height, so it's 0 times 1, which is 0. In the next section, we have a box that's 1 wide and it's 5 high, so we have an area of 5 times 1 or 5. Again, we have 0 in the next section, and then in the last section here, we go down 2, we go over 1, 2, 3, 4, so we have an area of negative 8, and it's negative because it's below the x-axis. The area is 8 for that rectangle, but when it's below the x-axis, we make it negative. So to connect that and draw the displacement time graph, we would start off by finding our start point. In this case, it is -3. Most of the problems that we will do, our start location is going to be 0. But in this case, our initial position is -3. What the area of 6 says to us is that over the time frame of that 6, which is 2 wide, 1, 2 wide, we are going to move in the y direction 6 units. So we count up 1, 2, 3, 4, 5, 6. We go up 6. And so now we are at the point 2, 3 from 0, -3. We then connect the dots. So you could see here, we are going to connect those dots. Then over the next 1 second, we change our y value, because what we are saying down here is we're changing our y value by 0. So over 1 second, I change my y value by 0. Next, I change my y value by 5 more, 5 positive. So in 1 second, I go over 1 second, I go up 5 units. So I go from 3 to 8. So I go up 5 units. 3 plus 5 is 8. It's 1 second, and I end up here. Again, we connect the dots. We then go 0. That is going to happen because there is no area, so there is no change in y over those 2 seconds. And then finally, over the next 4 seconds, 6 to 7 is 1, 7 to 8 is 2, 8 to 9 is 3, 9 to 10 is 4. Over those 4 seconds, I am going to have a drop of 8. So I'm going down -8. So I'm at 8, so 8 plus -8 gets me back to 0, and I end up at a displacement of 0. So that is how we handle that. The process of converting from velocity to displacement was taking area. If you look over on the left side of your screen, you will see that we have a box that shows the relationship between a position, velocity, and acceleration graph. If I have a velocity graph and I want to go to a position graph, I take the area. If I were to change the name of the graph on the bottom of the screen from velocity to acceleration, and I do the same steps I did here, then that would change this to a velocity graph. So if I change this to acceleration, then the graph at the top becomes velocity. The process of going from acceleration to velocity is the same as the process of going from velocity to position. And so if you can do one of them, you can do both. Same thing happens with slope. The process of going from position to velocity is the same as the process of going from velocity to acceleration. If you have any questions, let me know.